Hello, Reg audience. We are live with you today, talking about delivering applications at the edge and the benefits of platform engineering if you are going to be doing that. So, who's going to be talking about this today? It's Dave from Scale Computing. Hello, Dave.
Hello, how are you?
Good, thank you very much. Hope you're well as well. What do you do at Scale Computing?
I'm the Vice President of Product Strategy. I've been with Scale over 13 years, and I spend most of my day kind of working with the product engineering team and customers and partners on new problems, new solutions, kind of the leading edge innovative things that Scale's working on.
Okay, we are going to be digging into your full 13 years of knowledge about what Scale's doing
We'll see what
today.
we can dig up. Yeah.
Yeah. I imagine there's nothing that happens at Scale you don't know about by now. What are we going to be talking about today? We are going to be talking about how, if you are involved in edge computing, you want it to be resilient and scalable. We'll be looking about the benefits of virtualization and containerisation in particular in achieving this and how you deploy as well. One thing that we ought to start with, I guess, Dave, is if you tell us about scale computing in a bit more detail.
Yeah, it's a good starting point. Without we'll get into the product and technology quite a bit, but we're known as one of the leading vendors for hyper-converged infrastructure. So it's consolidated, easy to use, easy to manage application platform that integrates storage, compute, networking into a single system or a single platform. That's really been our bread and butter, over the majority of my time. We're seeing that now, expanding, well, have been seeing it for quite a while, expanding outside of decentralized data center out to distributed locations of all types of different use cases and for different reasons. And that's a lot of what we're going to talk about here is, how you take on-premises infrastructure, manage it in a very scalable way, in a very resilient way, and how IT organizations can essentially build an infrastructure platform, very much like what you're used to in the cloud, but for infrastructure that you own and infrastructure that's distributed where you need it to be. And one of the things that we've seen as a trend, really 10 years back, but it's just increasing exponentially, is the adoption of applications that really, for a variety of reasons that we'll talk about, need to be run at the edge. And the edge is, we're not going to split hairs and define
I
what
was
is
going
it.
to say that's a pretty big edge you've got marked there, Dave.
This is
But
yes,
people differ on
and
what the edge is, don't they?
well, I mean, we actually have kind of a simple definition of it. It's anything that's not a public cloud and not a centrally managed private cloud kind of data center. So
Right.
I mean, so pretty much anything out of that. So that can be everything out to individual devices that are collecting data, gateway type IoT applications that are receiving processing information from local machines, things that are actually doing computer vision, AI type inferencing, where, if you look at most of those applications, they're real time, they're just not practical to send all the data up to a public cloud, even milliseconds away, let it do its thing, get results back, and have that be a usable thing. So we really try to address this whole spectrum from, localized data centers, compute edge where you need resiliency, gateway type applications where you just need to process stuff and make sure that you have continuous processing, but maybe not the long-term data persistence. But what this means is a lot of things, a lot of places that you're deploying applications, updating infrastructure. And that's really what we've tried to focus on and build a platform-based solution for doing that.
Yeah, I'd imagine there are some particular common problems, challenges to deploying in all of these contexts as well, but also these contexts are very, very different. So it's a problem itself to be able to sort of cover this full spectrum.
Sure. Yeah, absolutely. And most IT organizations have gotten used to all the benefits you get with a public cloud. There's hardware underneath it you don't have to care or worry about in almost all cases. There's operating systems, there's infrastructure, there's networking that you just don't care about. We're
Hmm.
trying to kind of provide as much as we can that kind of that kind of platform in places where you have limited or no IT staff. I mean, a common use cases for us would be things like widely distributed retail stores, quick serve restaurants. An interesting one that we have several different customers that have adopted us are in the transportation industry, things like autonomous ships that are floating around the ocean with little or no network connectivity, running mission critical applications. And the definition of mission critical on that can range anything from navigation to the video entertainment system of what do these people do when they're out floating around for weeks at sea. But there's no IT people there to maintain things or even monitor things.
Exactly.
So,
You can't call one out in that situation,
well,
can you?
no, right, yeah. A tech there is a very expensive helicopter ride with some parts and things like that. And so, dealing with those environments, building an infrastructure platform, which we're going to keep coming back to, that is designed to
Mhm.
autonomously monitor itself, care and feed for itself, make corrections, and ultimately do whatever is possible to keep the application running is a big reason. And again, taking the network out of it. You have applications that cannot be reliant on, skipping ahead, connectivity outages, or sometimes even just network latency constraints. We do
Mhm.
see a lot of physical constraints in these environments. Most of these don't have, properly conditioned, chilled, cooled, powered data center type environments. So a lot of these are deploying, in an ocean going ship where you have about this much space, or in a quick serve restaurant, hopefully not immediately above the fry machines or things like that. But very different size, power, constraints that we see in these edge locations. That have to be addressed, and then just unpredictable demands. A few years ago, people had the luxury of saying, "Oh, we need to deploy this new on-premises point of sale system." Well, that's great. Let's start a project. Let's order hardware. Let's spec it out. Let's build a pilot. Let's do it slowly. That's no longer been acceptable. I mean, COVID was a great example where people had to really quickly, rapidly be prepared to deploy new applications that they weren't planning to just, weeks before. And so those that were prepared with a platform that had some level of scalability, some level of manageability, were able to respond to that quickly. And that's, I think, more and more customers, and what we're trying to enable is that kind of flexibility to let you deal with unpredictable demands, quickly scale up your application, quickly deploy new applications, quickly expand your resources. I mean, in the cloud, this is an easy thing. You just spin up some more things and they're magically always there whenever you need them. In distributed environments, it requires a little more planning, and it certainly requires a plan for how you scale out, how you add resources throughout their life cycle, to deploy and scale up when you need it. And then ultimately, 3, 5, 7 years down the line, how do you replace that infrastructure, without throwing everything out, forklifting upgrade, to a new type of system. So we're trying to help customers deal with all those kinds of demands.
Dave, one of our audience says, can we just quickly see that edge diagram again? Can you skip back to it?
Get back. Yeah.
Yeah. And DVR is looking at it. I
Sure.
just one thing I wanted to ask you
Yeah.
is what we're talking about today, is this a big company thing? Because I noticed from your logos you deal with some sort of pretty large multinational organizations, or is this a problem that's shared by medium-sized organizations as well?
It's really across the board. I mean, to be honest, I would consider remote office, branch office, an edge application, an edge use case that's been around for a long time. Now, in some cases, that's just because that's what they're comfortable with, or they didn't have maybe the public cloud, experience to move those applications. But some of those traditional applications just make sense from a cost or latency or performance or privacy, expectation to be able to keep those locally. So we do see these across companies of different sizes. I will say, obviously, the problems of, maybe there's some threshold. Well, if you've got 5 sites, you can get away doing things manually, more ad hoc
Hmm.
than if you've got 5,000 or 50,000. And in some cases, though, the geography, is a big issue too. If you're a day's drive to these locations, that's a different case than if they're distributed worldwide, and you need follow the sun 24/7 kinds of hardware, software, and infrastructure support.
And of course, that unpredictable demands thing again. If you got 5 sites and you move to 15, you're suddenly going to have to change your working practices.
Well, yeah, and that's what you want to design too, is you want to build
Yeah.
a scalable platform and design pattern that says, yeah, we can do that easily. We can scale up individual sites. We can deploy new applications, new resources, new types of resources. We before just needed general, Intel type CPU. Now we maybe need GPU resources or other offload kind of capabilities. How do we incorporate that into our platform and the services that we can provide by our platform without having to throw everything out and start over?
Can I let you move on? One thing,
Yeah.
guys, You can download the slides. There's a button to download the slides as well. So you can peruse them at your leisure, either during Dave's presentation or afterwards.
Exactly. All right, so I wanted to do a little high level, and we'll go into this deeper on, what Scale's approach to this problem is. Our overall solution we call Scale Computing Platform, and that's an important concept that we want to be the way that you can deploy applications of all types, and we'll get into some of the differences of legacy applications, cloud native, containerized applications. But there's a couple key things that we want to call out here. So one is if you just look at the hypercore piece, so this is the on-premises piece that takes and presents, server, compute, storage, provides the hypervisor layer so you can run different applications on shared infrastructure, other services like disaster recovery, whether that's remote replication, snapshots, integrated backup, resiliency, so you see at the bottom of that slide there, we've got 3 little compute devices, and this is actually one of our most popular platforms. They're based on, the Intel NUC kind of architecture, so the little 4-inch by 4-inch things. Cluster them together for storage, compute, resiliency, and be able to mass deploy those and then deploy applications on top of that. So that's an important piece, and we'll go through that. That's really kind of the underpinning of building. That's the piece that runs on-prem, aggregates all those resources together, presents them out to applications, whether they're legacy applications that are running in virtual machines, Linux, Windows type things, or virtual appliances, or if they are containerized applications that need, Docker runtime or need full-blown Kubernetes, type runtime, we can provide all those. The other key piece, and again, I think the degree of the importance here, certainly, if you have 10,000 sites versus 100 or 10, it's different, but everyone does need kind of centralized fleet management and visibility. So how do you centrally from day one deploy new resources? And so one of the things that the fleet manager piece on the left here, this is a cloud-based service that we provide, customers subscribe to. This is what gives them visibility to all of their sites, all of their infrastructure, all their applications from day one, even things, for example, like what we call zero-touch provisioning. So when you order hypercore systems and you say, okay, we're going to deploy these 10 systems out to these 10 sites, as soon as that order comes in, actually, before it's even shipped out the door, it shows up in the customer's fleet manager where they can go ahead and say, hey, I just ordered these, I'm deploying these out to these locations. Let me go ahead and pre-configure, some site-specific things like IP addressing schemes or metadata that describes, oh, well, this store needs to run these set of applications versus these other. They can go and basically pre-configure everything about that edge location such that when the infrastructure shows up, and these are, in this example, very simple devices, a store manager at a retail application could plug in the Ethernet and the power like they could a laptop, have these things phone home to fleet manager, get their instructions to configure themselves as a resilient cluster, get the instructions to have them automatically deploy the applications that need to be running, all without any IT expertise on site. And not everyone does that way or needs to do that way, but that's the level of automation and that we aim to provide. There are use cases where that's just critical to not have to, even for day one implementation, have to assume IT infrastructure. But certainly beyond that, you don't want to be rolling trucks every time, you have a bad RAM, device or a network hiccup or things like that. So, those are kind of some of the key points to talk about there on why these things are all important to cover all these boxes here. All right. So to talk about just kind of some of the different kinds of applications that are important to consider, virtual machines, and some people don't like the term legacy or legacy applications, but old Windows stuff that's been running there for a long time. We see a lot of
Windows stuff. That's the best
old
way
Windows
to describe.
stuff. Lots of old Windows stuff, and there's a lot of those that still exist, will continue to exist. And to be honest, a typical example, we'll go in and we were starting to work with a new prospect company. We'll look around. Well, what applications is it that you're running? What do you run in a grocery store, for example? And they'll say, well, we got point of sale, and they don't even recognize all the things. It's like, well, what's that box doing over there? Oh, that's video surveillance. Like, okay, you like having that standalone box doing just that, and what happens when that breaks, and what's that box there? It's like, oh, that's the environmental controls, and that controls the parking. It's like all these things that a lot of organizations, just getting an inventory of everything that's running out there is often difficult. And that's where, I think kind of, lifting and shifting, taking those workloads into a virtualized environment where you get just your normal benefits of consolidation, utilizing shared resources, being able to put it onto a resilient platform, take an application that today might be running, and this is no joke, on a 10-year-old XYZ brand server that they're scrambling to buy parts from eBay, putting it onto a resilient platform that just runs and takes care of itself with built-in backup and resiliency capabilities. I mean, that's an important capability. Being able to scale up those old applications, it's like, hey, you need some more CPU, you need some more RAM, you need more storage capability. Those are important things. And then even being able to standardize the deployment, of those applications across new sites, using infrastructure as code, using deployment automation, providing just hardware independence. So again, you don't have to get, I need this specific HBA card that's 10 years old. All those things are great benefits to even taking your existing applications, your legacy applications, putting them onto a resilient managed platform, and leveraging virtualization for those until or unless you're able to refactor those in a more cloud native, modernized way.
As part of this process, Dave, it strikes me that sometimes, for example, if you've got lots of small retail locations or something, the effect of going out and actually having a look at what there is there really concentrates minds, doesn't it? Because it is exactly as you described, sometimes stuff that's really held together with sticky tape.
Yeah, yeah. And in larger organizations, a lot of times it was different teams that deployed that. Well, the security team put that video box out there and nobody even recognized it was out there. So yeah, getting an inventory of what your requirements are. And this is really, the opportunity, I think, for modern IT organizations is to help the business overall do that inventory and then come back to them with a platform solution on how do we support all these different workloads, without, specific point products, point solutions, different ways of handling this application versus that application. So yeah, I think that's the way to look at those existing things. And then we are seeing, new applications that, I don't necessarily like the word cloud native. I put it in here, but we're designed to, in modern application development, so leveraging containers, leveraging open source. To me, cloud native generally does just mean containers and ideally non-monolithic. So it's not one big application, but it's an application that was designed to run with some level of scalability, some level of scale out if necessary. But kind of the key there is that, those applications do assume and require infrastructure that is very cloud-like. That's where they were built for. These ran on AWS and Azure and Google. So a certain level of resiliency is often assumed that, just taking bare metal hardware pieces out there is not going to cut. Scale up and scale out is kind of table stakes. So being able to, I think like we mentioned earlier, I showed that 3-node hypercore cluster. We have the ability to scale that out more, just keep adding nodes, and the entire system, can grow with the same or even dissimilar resources. Something that's API software driven. The ability to programmatically control the infrastructure, declaratively state these are what applications should be running, these are how they should be configured. And then ultimately from the application developers teams, ideally invisible. So if they've adopted, a certain way of building their applications, deploying their applications, testing their applications, that works great. Say they're, Google Anthos, Google Kubernetes engine. We want to be able to connect into that, let those application teams continue using the tooling, the stack that they're used to, but kind of incorporate the edge deployment into that. And so we've done a lot of things with those specific platforms to enable that kind of integration, so that ultimately, again, the application teams get what they want. And this is all, when we mentioned platform engineering.
Yeah,
that's kind of, I think, where this comes together, where the IT and operations teams define a platform, define the services that they expose out to those application teams, and the application teams are used to consuming them in a particular way. We want to help those IT teams build a platform that provides those infrastructure resources the way their application teams and even third-party companies expect to have access to them. So, and that's kind of what we're going to go through here. So just kind of putting it, all together visually. So this is, again, the scale computing platform, kind of the key On-premises piece being the hypercore system that leverages, hyperconverged integrated compute resources, allows all types of applications to be deployed, whether they are legacy virtual machines, whether they're containerized applications, provide standardized services, like storage capabilities, API access, so forth. And then when you layer on top of that, kind of from the infrastructure team, the IT operations, the pieces that they need to distribute, access that across an entire fleet. We talked about our scale computing fleet manager platform that is providing centralized monitoring, centralized policy, centralized control for everything, for the infrastructure, for the applications, and from day one to day end. So I talked through the scenario of zero touch provisioning, where Fleet Manager is kind of the hub for that. As new sites are deployed, or even as new applications need to be deployed on new sites or existing sites, that goes through Fleet Manager to make those available. And then from the application teams, they're just consuming the platform that's provided by IT. So, they understand things like, well, all right, here's how I package up my legacy virtual machine and push it out, and I give that to the IT team, and they can then make sure that that gets applied properly to the platform, or, in a more dynamic, cloud native type of application, they may be using existing tools, as we mentioned, maybe they're deploying and testing on Azure and Azure Kubernetes Service, AKS. They get to a point where it's okay, now we're ready to release this new edge-based application out to 10,000 edge sites. We can help with do that integration so that you can basically have application development lifecycle flow all the way from public cloud down to multiple edge locations. Give the IT team the visibility and the responsibility for the infrastructure, the physical deployment, management, maintenance, care and feeding of that, and kind of hide all that from the application teams. They just consume the services that are provided there in the same way, same kind of patterns and deployments of what they're used to in a public cloud or in their test dev environment. And they can then, distribute those applications across a much larger fleet.
Dave, can you tell me a little bit about how this helps to deliver secure applications?
Well, yeah, I mean, so security is kind of built in, from today, particularly on the cloud native and modernized applications, we see security being just part of the pipeline. So whether it's SBOM, software bomb inspection of making sure that all the layers and pieces incorporated in the application meet security requirements, that can be all done at the application deployment pipeline. Even in virtual machines, you can integrate, I have this new image of my application. I want to push out this new cloud image. You can and should run those through security processes. I guess we haven't talked about it a lot here. I mean, we've mentioned infrastructure as code. That often equates to what's commonly referred to as GitOps. So you have basically defined your applications, defined your sites, defined, testing that required in some type of version control system, a Git repository, things like that, as you make changes to, okay, I want to rev my application or my image or do apply patching, I go and change that, basically do a commit, in a Git repository that triggers a set of automatic testing. Whatever testing is involved there, it's like, okay, I run through and I run Nessus scans. I do an SBOM analysis on my containers. I, do a quality of service check that my application output is still, meeting its guarantees and so forth. And once I've gone through all that, then it's approved for mass deployment. And even that can be, stage gate. Well, let's deploy to some canary sites first and, make sure that the application rollout is happening in the same way across these many locations. And these problems are much harder to do in the edge deployment than they even are in a public cloud, even if you have, a bunch of different regions, a bunch of different zones. It's some of the same problems, but, oftentimes 1,000 or more. It's like,
yeah.
So yeah, so security is definitely a key part of why you want to have this approach, why you want to integrate with those existing pipelines and so forth. All right. So again, to make this all possible, it's obvious you can't just, drop hardware from the sky into these sites, do manual configuration, have, mismatch of hardware components, software stacks, things like that. You need to, for this to operate, you need infrastructure that is autonomous, that can essentially care for itself, where you can specify the desired amount of availability. How much redundancy do I want to build into the system? It's got to be simple from deployment, from expansion. And as I mentioned earlier, kind of that scenario of a store manager plugging in a standard device that's got a network port and a power port. And by the way, many customers actually, if it's a net new deployment, ship that out in one box, and they're all in a little 6U rack that they hoist up to the ceiling and gets plugged in and runs. A bunch of different ways of deploying, simplifying the deployment of that with the assumption that there's no IT resources available on an ongoing basis. That's really key. Efficiency is really key, and we didn't really get time to get too much into the under the hood, but the way we've designed HyperCore and the level of integration that's built in, where everything is provided in our underlying bare metal operating system, the storage stack, the management infrastructure. We're not using, we didn't just take basically a software storage device, a software SAN, put it into a virtual machine and plumb it all together. We designed and assumed that this is going to, for cost reasons, for space and power reasons, need to run very, very efficiently on very small form factor devices. So we did a lot of integration. That's why we can run on, for example, things like the Intel NUCs and even smaller devices that might have 8 gig of RAM and 4 cores of CPU. And then depending on what's needed, we obviously go much larger than that to full rack scale devices where they're needed, or GPU loaded devices are available. But efficiency is really one of the keys. We often, in the retail space, we'll get cost compared to, how many bananas that cost to add that? It's like, cost is a very critical factor in a number of, for everybody.
Margins are very low in these sort of organizations.
Exactly. Yeah. And when you're talking about, what seems like a small cost multiplied across 10,000 locations, you're always talking real money. But then, flexibility being a key. And I think I've given a couple of examples here of, we designed our system to not assume, for example, in a resilient cluster HyperCore, that everything is the same. We want to make sure that you can buy what you need today, add new and different and better and cheaper kind of resources, down the line, do things like, hey, if you need to now deploy, GPU-based applications for inference or things like that, that you can just, through the same process, through Fleet Manager, order the system, zero touch, deploy them into an existing cluster, deploy the applications on top of those exactly the same way, that you would do anything else. That's really a key. So the flexibility of being able to change that system, expand it with, any kind of resources is very key. And the end result is that, we aim to provide a platform that gives you cloud-like management for a very widely distributed edge. So you can choose what level of availability, what scalability do you need. You have automation both to deploy that infrastructure, to deploy applications on that infrastructure, to update the applications and infrastructure, and then built-in automation that just kind of keeps the system running by itself, that really you don't even need to care about. That's just kind of part of the platform, like in the public cloud. You don't worry about what, Amazon or Google are doing with, the machines and the under the hood infrastructure stack. That's the approach that we take with HyperCore. That results in an ease of use capability that's really unmatched, a very efficient platform that's cost effective, and lets you as an IT organization be business centric. What are the services you need to provide for your developers? How do you expose those? What are the products that you're offering your application teams? And focus on the pieces that are beneficial to the business, not the underlying care and feeding of the hardware, which is important and is hard and is very very costly if not addressed correctly.
And I guess that changing ways in which we're doing business, they imply that we are collecting more data at the edge, we're processing more data at the edge. So it turns out that the way that we're doing business is driving this change.
Oh yeah, absolutely. I mean, there's lots of great metrics and statistics. The one that jumps out, may get the number off a little bit. I mean, it's estimated within the next few years, 70 to 80% of all data generated will be created and consumed at edge locations. And that makes sense when you look at video-based data, all the just stream analytics, all the IoT type stuff is just collecting, processing, making decisions. And a lot of that is sensitive information that you don't want to send or store at, elsewhere, send off the network or keep, within keep within a region for privacy purposes, things like that. A lot of it doesn't have much value beyond, okay, I do the analytics, I make the decisions, I keep the metrics, but then I can, throw that away. There's increasing number of applications like that, particularly with computer vision, AI, ML, kind of operate that way in the most part. So yeah, just enormous amount of data growing, and most of it, the fastest growth of it is in these edge locations.
Yeah, I guess the reason I say that is because I guess if your app deployment for edge locations is a bit of a mess now, and you're more or less keeping on top of it, but you don't think you're doing very well about it, well, these problems are going to sneak up on you pretty quick.
Yeah, yeah, and I'd say more often than not, what actually happens is you have had, and we see a lot of customers who they haven't even fully deployed. Like they start with, okay, this works great, and it works great in our pilot, and then it worked great on 5 sites, and then it all fell apart, and
Right.
it's like, and so they're now kind of going back to the drawing board and helping, well, how do I build a platform and an infrastructure solution that is really designed not to just operate, in a small pilot environment, but I can design and test and verify that this is scalable across a very large number of locations. So that's kind of I think one of the key thinkings here is think platform, think scalability, think not just the one-offs. Make sure you have automation at every layer, from the infrastructure to your application deployment and so forth.
Well, so I'm going to ask the question that I ask everyone at this time in our Regcast, Dave.
Yeah.
If you need to start on this now, this week, today, what do you do? Where do you start? Because this is not a small problem to solve.
Sure. Yeah, as far as it's kind of the tech sides, we've got some good resources on our website that are hyperlinked here that talk about management of applications, talk about containerization. I think separately, within your organizations, going through and doing some of the mental exercise, digging through that deeper mental inventory of, oh yeah, what is out in these locations? What locations do I care about? What data are they generating? What are the privacy constraints on that? What new applications, is the business unit going to come and possibly expect me to deploy in the next month here, a couple years, and start thinking through, how are you enabled to do that when you're asked. But kind of going through the mental inventory, being prepared for that. And by the way, this is designed. Our solution is designed that you can start small. So this isn't a massive, like, I need, data centers built out in every edge location. Some of these are just single nodes in some cases, but you need that, that fleet managed deployment. You need that visibility, and you can scale out from even a non-resilient system to a resilient cluster down the line. We want to offer all that kind of flexibility, be able to, start with where you are today and what you need today. That's a kind of another key, versus you don't have to predict everything for sure and go buy what you need in the next 3 years. Start with what you need today, get the platform in place, get the processes built and in place. And as we've talked about, you can add the resources you need, when those applications are down the line, but you have a thought through plan and method for how you would do that quickly.
I guess it's possible to underestimate the difficulty of getting those processes in place.
I mean, for different organizations, there's political constraints, there's, all types of things. So yeah, thinking about it, starting early, getting, executive level buy-in on, what's the risk of the company if we don't have the ability to quickly react to business needs. And I mean, we are hearing and we're seeing customers do it where it's like surprise applications that used to be, well, all right, this is going to take us a year or two to, get everything out and actually get hardware deployed. People are deploying brand new applications in weeks or months, and that's game changing. That's for the business, and that's a huge competitive advantage.
All right, that's all we got time for, Dave. Thank you very much for talking to me about that.
Thank you. I enjoyed it.
Yeah, and we hope that all of you enjoyed it as well, and you found something useful in that. This stuff is hugely important and really difficult. So if you want us to do some more about it, let us know, and of course we will. But for today, I'd like to thank everyone behind the scenes at the Register for putting this on. Thank you, the audience, for showing up to watch it and for asking your questions. Just remains for me to say, for me, Tim Phillips. See you soon. Goodbye.